This is Mr. Martin. These are the video notes for Pre-Calculus Honors Section 6.1. This is the first day that we're going to talk about law of sines. So we have studied quite in depth about solving right triangles. We have lots of different methods. You can use Pythagorean theorem. You can use SOHCAHTOA. We have lots of different ways to solve right triangles, but suppose we don't have a right triangle and we want to find missing parts of it. So the kinds of triangles that we'll be dealing with are called oblique triangles. Okay, these are non-right triangles. So basically we've got obtuse and acute. Alright, so we want to solve, meaning find the missing parts of these oblique triangles. So as we go through and learn different methods for solving oblique triangles, we're going to have several different methods. The key here is that we need 3 pieces of information to solve an oblique triangle. And the 3 pieces of information that we're given will determine what case we have and what method we'll use to solve it. So the first case is given any 2 angles and a side. So it could be 2 angles and the included side, angle, side, angle, or it could be angle, angle, side, where the side is not included. Alright, so given any 2 angles and 1 side. Alright, so that's our first case. And the way you're going to know what case, probably the best way to figure it out, is just to draw a little sketch and then write in the information that you have. So case 2, this is the side-side angle case. And if you remember from geometry, this was one of those cases where you could not prove triangle congruency, because given 2 sides, the length of 2 sides, and an angle that's not included between the 2 sides, sometimes you can either get no triangle, or sometimes there's one possible triangle, or sometimes there might be 2 possible triangles. So there was no guarantee of congruence based on this information. So side-side angle, we are given 2 sides and a non-included angle. Okay, this is called the ambiguous case. And there may be 0, 1, or 2 possible solutions. Alright, and we'll talk in another video about how to figure out whether there's 0, 1, or 2 solutions. So that's case 2, and section 6.1 is really going to be dealing with these 2 cases, section 6.1. Now the other 2 cases, which will need a different method than cases 1 and 2. So for case 3, we've got side, angle, side. So given 2 sides and the included angle, and we'll have a method for solving that. And then the last case is the side, side, side case, given the lengths of 3 sides of a triangle, and then we'll go ahead and find the missing angles. So those are our 4 cases. Today really we're going to be focusing on case 1. So let's take a look at a couple of examples. For case 1, we're going to use what's called the law of sines. And we're not going to talk about how to derive the law of sines in this video. We'll probably talk about this one day in class. But the law of sines is what you're going to use when you're given 2 angles and any side. So what you notice here is we have the sine of angle A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over side C. And again, you want to make sure that you're using this for oblique triangles, because if you have a right triangle, then you're going to use a different method. Now, we can also flip all of these over so that you could have A over sine of A is equal to B over sine of B, which is equal to C over sine of C. Notice I put a little tail on my lowercase c so there's no confusion. So I'll usually use the form of these for whatever I'm trying to find. So if I'm trying to find sides, I'll use the bottom sets just because it takes a step out of solving the proportion. Or if I'm looking for the angles, I'll use the top sets. So let's go ahead and take a look at an example. We have a side angle case. Again, first step is always recommended that you draw a little picture. It really doesn't matter what it looks like. I'll usually draw the same triangle every time. So I've got ABC. I've got A is 40 degrees, B is 60 degrees, and side A, which is going to be opposite angle A, side A is opposite angle A, is going to be 4. And then what I do is I usually make myself a little table of the 3 angles and the 3 sides. And I'll fill in what I know. I know this is 40 degrees, I know this is 60 degrees, and I know this is 4. So then I know that I'm looking for these 3 pieces of information. Alright, so if you notice, when you're using law of sines, you have to be given one angle and one side that goes with it. So in this case, we are given this. So let's keep that in mind. And then we know from geometry that the sum of the 3 angles in a triangle is 180. Since I know 2 of these, I can find the third one. So I know that angle C is going to be 180 minus 40 plus 60. So that's going to give us 80 degrees. So I know that angle C is 80 degrees. And now I'm going to use this highlighted side and angle to help me find the other 2 sides. So I've got B over the sine of 60 is equal to 4 over the sine of 40. And then if I, really all I have to do is cross multiply this way, so I'll have 4 sine 60, make sure you close your parentheses on your calculator and make sure you're in degree mode, divided by sine 40, and we should get that B is approximately 5.389. So if you want to pause the video and make sure that you get that number. And then we could do the same thing with C. We've got C over the sine of 80 degrees, and I'm going to use the same proportion or same ratio, 4 over sine of 40, and we go ahead and solve that for C, and we should get that C is approximately 6.128. Alright, so as always, if you have questions, make sure you pause the video and write those down. So at this point, you can either keep the video rolling and you'll see the solution of this pop right up, or you can pause the video and work it out and see if you get the same answers as me, and I'll have all my work here. Before I put the solution up, I'm just going to label my triangle ABC, and then we can go ahead and put this angle as 45, this angle is 95. Obviously you can see this is not to scale. The side opposite angle C is side C, and we need to find angle B, side A, and side B. I'm going to make my chart here, ABC, and here's side A, side B, and side C. I know this is 45, I know this is 95, and I know side C is 5. So I'm looking for these 3 pieces of information. So again, at this point, go ahead and pause the video, work out the rest of the solution, and restart when you're ready to check your answer. Alright, so here's the solution for the second example. You should have gotten 40 for angle B. and 3.549 for A, and 3.226 for B. If you didn't get those answers, maybe you want to double check your work with my work. And as far as what work I'm looking for on quizzes and tests, show me your calculations for angles. Okay, so I want to see that you're setting up with this equation, subtracting the two angles from 180. And then just show me the proportions that you're setting up to find the sides. You don't have to show me all the work for solving those proportions, but I do need to see the proportions. Alright, so let's move on to case 2, angle side angle. We want to solve this triangle. Again, I'm going to draw my generic triangle. I've got A and B and C, and I've got 35 here, side A across from that, 15 here, and side C is 5, and here's side B. So I'm going to make my chart of answers, help keep me organized. And I've got C is 5, A is 35 degrees, B is 15 degrees, and I'm looking for these three pieces of information here. Alright, so I can go ahead and find angle C right away. That's going to be 180 minus the sum of 35 plus 15. So that's going to give me 130. So I've got 130 here now. And now I have my side and an angle that goes with it. And this is going to allow me to use law of sines. So let's find A first. I've got A over sine 35, and I know that's going to be B over the sine of 15 degrees, which has to be 5 over the sine of 130 degrees. So A is going to be approximately 3.744. Again, pause it anytime you need to do your calculations. And B is going to be about 1.689. So that's 3.744 and 1.689. Alright, and then last example for the notes here. Go ahead and give this one a try. Again, pause the video, and when you restart it, the answer will come up. Alright, so here's the solution for the last example for this video. And notice since two of these sides are both 40, we've got an isosceles triangle. So the two sides that I found over here, they should be congruent. You know, since we're using the same ratio over here, they're going to be congruent. And you should have gotten about 1.305 for both of the sides. As always, make sure you're doing the practice problems. If you had any trouble with the video, make sure you pause it and write down your questions and ask me. And we will see you in the next video.